All right, this lesson is on area of regular polygons. Just as a review, when you see this word regular, it means that all the sides are congruent and all the angles are congruent. Okay. So you can see this picture off to the side. You see how there's a circle, and inside that circle there is a hexagon. So we would say that the hexagon is inscribed. It's inscribed into the circle. And you can see here the center. That's pretty straightforward. That's easy to understand. It's the middle of the circle. And then the radius, so if you already know with a circle, if you go from the center to the edge of the circle, that's the radius. And if you look at your polygon here with the hexagon, it goes from the center to the vertex, to the angle. So make sure you understand that. And then apothem, you go from the center to the other side. So make sure you understand the difference. So radius goes from center to vertex. Apothem goes from center to the side. It has to be perpendicular. And if it's a regular polygon, it's going to bisect that angle and it's going to divide the triangle into two equal triangles in half. Because this is a circle around, so if you say like the circle is around, it's really the circle is circumscribed around the hexagon. The hexagon is inscribed, and we'll kind of use those words here in some future lessons, but just so you kind of know. It all has to do with a circle. So all of these inside angles here, obviously they're all going to be congruent, but we know that a circle has 360 degrees. So if I take 360 and I divide by how many angles I have at the center, which matches the number of sides that the polygon has, in this case 6, I'm going to divide it by 6, and that would give me 60. So really, this should be up here. So each of these angles is 60. Now, if I do the same thing for this next figure, how many sides do I have? 5. It's a pentagon. So instead of dividing by 6, I'm going to take this, and I'm going to divide it by 5. And so when I take 360 divided by 5, you get 72. So each of these angles up here is 72. But if you get to the one right here where it has the apothem, it cuts it in half. So half of 72 is 36. So angle 1 is 72. That's what we call a central angle. Angle 2 is cut in half, so that's 36. And then angle 3, all three of these have to add up to be 180. So what I would do is just find out what's left over from 180 from the other two. So really I have 90. 90 minus 36 is 54. Okay, so you'll just change, depending on your shape, you'll just change this bottom number, what you divide by, but you'll always take 360 if you're trying to find those angles. This is an example, or here is not an example, but the formula that you're going to use when you find the area of a regular polygon. So, and it tells you exactly what it is. The area of a regular polygon is half the product of the apothem and the perimeter. So perimeter we know is the distance around the edges, and the apothem goes from the center perpendicular to a side. So think of it as like a height of the triangle. So if I look at this here, if I start with my perimeter, I have a decagon, so that means I have 10 sides, and each side is 8, so my perimeter is 80. The apothem, sometimes they'll give it to you, sometimes they won't. So you might have to use some trigonometry or the Pythagorean theorem to help you find the apothem. But they do give me from the center to the side. So 12.3 is my apothem. And then I'm going to sub it into my formula. A equals 1/2 times the apothem, which is 12.3 times 80. And hopefully you are getting used to, well, 2 divided by be 2, and 80 can turn into 40. And that just saves you a little bit of time, and you can take 40 times 12.3, and you get 492. And this is area, so it would be inches squared. And that is your answer. The next one, what is the area of a regular pentagon? So pentagon, we know we have 5 with 8 centimeter apothem and 11.6 centimeter sides. So my perimeter, I'm going to take 5 because I have 5 sides and each of them are 11.6. So 5 times 11.6 is 58. And then my apothem they give me is 8. So A equals 1/2 8 times 58. 2 becomes 1, 8 becomes 4. So 4 times 58 is 232. And then don't forget your label, so centimeters squared. All right, the next one. A honeycomb is made up of regular hexagonal cells. The length of the side of a cell is 3 centimeters. So hexagon, 6 sides. So I'm just going to draw a picture. It doesn't have to be beautiful. So I know the sides are 3. So each side is 3 because it's a regular hexagon. Here's my center. So if I just draw like one triangle, I can fit 6 of these triangles in this shape. So 360 divided by 6 is 60. And the reason I'm doing this is because I don't know what the apothem is. So really, if I were to draw the apothem, it goes from the center perpendicular here to the other side, and it cuts it in half. So if this whole length is 1.5 or 3, then just half of it is 1.5. I'm going to draw that triangle just a little bit bigger here. So this is 1.5. This whole thing, the whole angle, both of them put together is 60. So if I cut it in half, then this is just 30 degrees and this is 60. And if you remember from a few lessons ago, you have a special right triangle. So opposite of the 30 is your x. Opposite of the 60 is x times the square root of 3. And the hypotenuse is 2x. Okay, so if you didn't learn that, it makes it a real struggle. It just keeps building on. But the apothem is this length here on this side. So I already know what x is. So my apothem is going to be 1.5 times the square root of 3. My perimeter is going to be 3 times 6, which is 18. So my area equals half the apothem, which is 1.5 times the square root of 3 times the perimeter. 2 is gone. 18 becomes a 9. And then if it were me, I would just multiply the 9 and the 1.5 together, and you get 13.5. And I would leave it with the square root of 3. You can also take and multiply the square root of 3 by 13.5 in your calculator. Let me see. I don't know what that actually is. 23.4. And get a decimal. And then let's see. This is in millimeters. So either way is fine. Radical form or decimal form. So similar to that, the side of a regular hexagon is 16. So if I draw my hexagon here, each side is 16. So if I make my triangle, that's kind of bad. We already know that this is 60. So if I cut it in half, that means this angle up here is 30. This one's 60. Half of my 16 would be 8, so this side is 8. That's my x. Then this side would be 8 square root 3. And this side would be 2 times 8, which is 16. So my perimeter, I'm going to take 16 times 6. Excuse me. So 16 times 6, oops, is 96. And then the apothem was this side here, the height of it, which is 8 square root 3. So my area is half the apothem times the perimeter. The 2 cancels to be a 1. The 8 becomes a 4. And then I would take 4 times 96. You put 384 times the square root of 3. Or if you want the decimal, it's like 665.1. And then that would be feet. So either one of those is fine. Okay. All right, let's look at these last 4. So we might have to do a little bit of work because like on number 1, yay, it looks like a square, probably maybe a rectangle, but I don't know the side length. So I'm going to make a triangle. This time I know the apothem, so I'm going to come over here. So this is number 1. So again, if I drew a circle around that square, I have 360 divided by 4, which is 90. So if I made this, then this whole thing right here is a 90-degree angle. If I divide that by 2, it's 45. So if I draw half of that triangle, like this part right here, this would be 45. This is 45, and then here's my 90. We know that it's x, x, and then x square root 2. So if I know that this is 5, then this side is 5, and I really don't need to know this for this problem. So if this side is 5, then this side is 5, and the whole thing is 10. So for my area, I don't have to do the apothem, half apothem times perimeter. You can if you want, but it'd be easier if you just take 10 times 10, which is 100. And that would be inches squared. Okay, number 2, it's a hexagon. So here's my center. If I divide that into 6 different triangles, we know that's 60. But if I cut it in half, let's just draw 1 half of it. Then this is 30, 60, and then your 90 here. It cuts it in half. So this would be 1.5. And my apothem would be 1.5 times the square root of 3. So on number 2, my perimeter is going to be 6 times 3, which is 18. My apothem we just found was 1.5 times the square root of 3. So 1/2 times 1.5 square root 3 times 18. That cancels out. That becomes a 9. I think we did this one already, just in a different format. So if I take 1.5 times 9, that's 13.5 square root 3, or like we had up here on this one right here with the honeycomb, 23.4. And this one's though in feet. So there is your answer for number 2. Number 3, again, if I divide this into triangles, I have 3 different triangles. So 360 divided by 3 is 120. And then 120 divided by 2 is 60. So if I divide that by 2, and then I'm going to draw just a bigger triangle here. Oops. Sorry about that. That's a pretty good part of a hyperbola. Anyway, we'll talk about that next year. Okay, so this angle is 60. That means this one is 30. This is my x. Now you have to ask yourself, is this 2? Is it a radius or an apothem? Since it goes from the center, or the centroid, to a corner or a vertex, that's actually a radius. And that's going to be the hypotenuse, which is 2. So this side was x square root 3. This side was 2x. So if 2x equals 2, that means x is 1. So my apothem is 1. because it's at height, right? And that would be the same everywhere. Right here, that's perpendicular. So the apothem is 1. My perimeter, I still need to figure that out. So if my x is 1, then this side is just the square root of 3, which is this side. So all of these have 2 square root 3. So all of this is 2 square root 3. So if I have 2 square root 3 times 3 sides, I only multiply the outside numbers together and I get 6 square root 3. So area equals 1/2 times 1 times 6 square root 3, or 3 square root 3 is your final answer. If you want to write it as a decimal, you certainly can. 3 square root, times 3, I think it's about 5.2 maybe. And then meters squared. So either way is fine. And then one more. So this is my apothem. So I don't have to worry about that. But I do need to find this side. So again, I have a hexagon. So if I make my triangle, I know that this angle here is 30. This one down here is 60. My apothem across from 60 is x square root 3. So that means my x is 4. And that side would be 4. Which then the whole side is 8. So my perimeter is going to be 8 times 6, which is 48. Half of 4 square root 3 times 48. 4 becomes a 2. So 2 times 48 is 96. Square root 3. And then this one doesn't have a label, does it? So we'll just leave it units squared. If you multiply it out, I have the square root of 3 times 96, about 166.3 square units. So hopefully that makes sense. There are a lot that you have to build off of. So take your time and just go through slowly, find each piece, make sure you know the apothem, and then find your perimeter and then sub it all in. So if you don't know your 30, 60, 90 triangles or your 45, 45, 90, you might want to take a refresher of those and make sure you remember those. So good luck.